So I'm going to start you off. I'm going to start you off with a quiz, okay? And we'll come back to this at the end. I've got 3 objects here. I've got a very neat little wooden bookend made by a local craftsman in the West Country. It's made of wood. I should be able to tell you what sort of wood it is. I haven't got a clue, and I can't promise it was sustainably sourced, but it is wood, and it's got a piece of cork on the bottom of it as well. I've got an onion, and I've got an old sock. Okay? Now, there's going to be a prize for the best answer from a table that can tell me what these 3 things have in common and which is the odd one out. What have they got in common and which is the odd one out? There isn't a right answer. It's the best answer, okay? So think about that. Put it in background processing. I'm going to put those there, partly to remind me to do something with them at the end. And then I have a few other things which I'm going to go around the tables with. So that's for you. That's for you. Don't eat them. That's for you. You will get some lunch shortly. That's for you. And that's for you. Have a look at what you've got. And I'm going to ask each table just to tell me what they've got. Okay, we haven't got much time. I'm going to start with what I hope will be the easiest. This table, can you tell me what you've got? Potato. You've got a potato. Can you hold it up? You've got a potato. Great. What have you got on here?
We're not quite sure. We think it's a layer of lasagna or some kind of Asian food. Not sure.
It is exactly a sheet of lasagna. Well done. What have you got over there?
Rice.
You've got some rice. Okay, what have you got here? You've got a slice of bread and you've got some sweet corn. Anyone have any idea why I picked those 5 things?
Because they're all staples.
They're all staples, yes, whatever we might mean by staples. What food group would we probably put them in? Carbohydrates, yeah. Definitely, if we were doing the kind of, protein, carbohydrate, fat, sugar thing, they'd definitely be carbohydrates, as is sugar, of course. What are they made from?
Starch.
They've got a lot of starch in them. They're all made from plants. Which plants? Which ones are made from wheat? Lasagna and the bread? Rice is rice. It's the seed of a plant. Maize, yeah, sweet corn, they're actually the fruits of the maize plant. Tuber, it's a potato tuber, which is, interestingly, although it grows below ground, botanically is actually a stem. They are the 4 most significant food plants that we grow on the planet. Rice, wheat, maize, and potatoes. And the first 3 of those provide us as a species globally with half the calories we get from plants in our diet. I think one of the issues we need to think about in this exercise is how are we going to help young people understand the connection between what they eat and where it comes from. And the fact that most of what you eat, if it isn't a plant, it ate a plant. And most of those plants are actually kinds of grass. Rice, wheat and maize are all grasses. And we eat a lot of them, but as Tim's just pointed out, we also grow an awful lot of it that we then feed to things which we then eat. So we're absolutely and utterly dependent on plants for our diet. And the way in which we manage those plants is both very good and also slightly problematic. And I'm going to stick for a moment with the potato. And that's partly because I'm Irish and I eat a lot of potatoes. There are huge cultural resonances. Those 4 different things that I've just talked to you about, we now eat all of them in our diet because we've globalised the cuisine in Britain. But actually, in the origins of the cultures who adopted them and who grow them, they are still a much larger part of the diet. So you heard Limewe at the beginning, talking about how different staples are grown in different parts of Africa, for example. And by and large, our cultural heartland staples are determined by where we live because they're determined by our climate. So the reason they don't grow wheat in the middle part of Africa is because you can't grow wheat in the middle part of Africa. It's too dry, it's too hot, they won't grow. The only reason you would ever grow cassava is because nothing else will grow. And I can, if you want to know more about why, I mean, in fact, I suspect that cassava is pretty close to celery in that the effort taken to prepare it and digest it is greater than any value you'll extract from it, but that's another story. So let's stick with the potatoes. And just in case you haven't examined a potato closely recently, because I do wonder, and this is an interesting question, perhaps more so for 14-year-olds than for you, have they ever even seen a potato close up? Okay. So you've all got sight of a potato now. Now, I think potatoes are completely magic. And the reason they're completely magic for me is that if you plant one of these, and so long as you give it a bit of water and a little bit of light and a little bit of TLC, in about 2 months, you will have a little bowl full of them. So if you give people potatoes to grow, they can not only eat them, they can also grow them, and they can grow them sustainably. And you just save some of the potatoes every year, and you put them back in the ground, and they will make more potatoes. And in Ireland, that was how the vast majority of the population survived. Because the other thing about potatoes, I'm talking now about the 19th century, the other great thing about potatoes, we tend to think of them as being on the naughty step, don't we? Not good food. Actually, if you can eat potatoes and you've got access to a little bit of dairy, a bit of butter, a bit of milk, perhaps you know somebody who's got a cow, can help supplement you, because the only thing you're not going to get from these is fat-soluble vitamins, vitamins A and D. Now, I'm not advocating it as the perfect diet, but it certainly works as a subsistence diet. You can feed your family on potatoes and a little bit of dairy, and you will all survive. And in the middle of the 19th century, the Irish peasant farmers could rent an acre of land, and on an acre of land, you can grow enough potatoes to feed a family for a year. Because you can get 3 times as much potato off an acre as you can get grain. So that's why they grew potatoes. Now, the magic of the potato, the fact that you can just take it and keep burying it in the ground and going back and there'll be more, your real kind of pot of gold story, if you like. The problem with that is that something bad happens to the genetic diversity of the potato if you do that. Now, the original potato probably looked a little bit more like this one. It was very small, quite dark coloured actually. Anyone know where they came from? They did come from South America. Probably most 14-year-olds would say Tesco's. And actually this one did come from Tesco's. But they came originally from South America. In fact, even more precisely than that, they came from very close to a place called Chiloé in southern central Chile originally. How do we know that? Well, everybody's watched CSI, haven't they? Or heard of it? How do you always know who's been somewhere and where something's come from in CSI? What's the one test that reveals everything? DNA testing, absolutely. DNA testing. Possibly most 14-year-olds don't even realise that potatoes have DNA. Okay. Of course, every living thing has DNA, with very, very few exceptions. What's even more surprising is how much of that DNA we actually share, as an aside. I mean, Brian, you probably didn't realise that your banana is pretty close to being a relative, because over 60% of its DNA is, between humans and bananas, is common. So, there's DNA in everything, okay? And it's very small differences in that DNA that can tell us an awful lot. So from DNA testing, we know that all the potatoes grown across the world, and we've got about 2,000 varieties of them now that are grown commercially, all originally came from these plants in South America. How long have they been in the UK? Well, they were brought over by Walter Raleigh. We've had them for about 500 years, and we've grown them. And very often, we've grown them from what are unhelpfully called seed potatoes, because they're not seeds. Seeds are the result of sexual reproduction, and they're quite varied. These are the result of just vegetative reproduction. They're all the same. So in the middle of the 19th century, the Irish peasant population was completely dependent on fields full of something called Irish lumpers. That was the variety of potato they grew, and they were all genetically as near as makes no difference. So when an unwelcome visitor from Mexico blew in on the breeze, literally, the spores of a fungus, it went through that population like a knife through butter. There was no variation. And so they lost the entire crop. It's a little bit, there was no variation. So if you think about a human analogy, all right, we're all here today. Just imagine that one of us has got a cold, okay? And we've been in the room with them all day. Well, the chances are not everybody in the room will catch that cold, because we're not genetically identical. There are other factors, but so some of us will have had resistance to that. We might have been exposed to it before, we won't all get it. But if you're all identical, if you're all clones, you all get the disease. And so in the space of about 5 years, about 1 million people died of starvation, because they tried regrowing the potatoes, the spores were in the soil, the crops kept getting infected, there was no resistance, and they just starved. And about 2 million people left Ireland. Huge exodus, went off to America mostly, a lot also to Britain. That's why there are a lot of people of Irish ancestry in Britain. And it was a national tragedy. There was a heavy political element also, because at the same time, British landowners were growing corn, wheat in Ireland, and they were transporting it back to sell for high prices in Britain. So people were starving when they were surrounded by fields of corn which they were not allowed to buy and couldn't afford to buy. Very, very political story. But at the heart of it is the problem of lack of biodiversity. So how we breed and how we grow plants is phenomenally important. Tim made that passing reference to the importance of biodiversity. And often people who know what biodiversity is, and there are still people who think it's a washing powder, biodiversity, of course, is, if you like, it's the abundance of nature, if you want to be spiritual about it. It's the variety of living things on the planet. And every time we allow something to become extinct, we lose biodiversity. And why does that matter? Well, it matters because diversity means resilience. So, for example, going back to the potato, there will have been in the wild a range of potatoes, many of which will have been resistant to Phytophthora, the potato blight fungus. If some of that genetic variety had been in the crops of potatoes in Ireland, some of those potatoes would have survived, and they would not have had famine at the scale they had. So genetic diversity really matters. That's a historic story. It's a nice simple story, so it's relatively easy to tell. But to assume that that story no longer applies in the modern day would be a very foolish thing to do. In India currently, they are losing varieties of rice that have been cultivated for generations. Literally thousands of varieties of rice are disappearing every year. And it's a political issue. There are political and economic forces that mean that the majority of the rice crop in India, if it isn't already, will very soon be basmati rice. One variety of rice. Where you used to have fields with genetically varied rice growing in different parts and different fields, you've now got vast monocultures of genetically identical rice. Any disease that hits that crop is going to go through it in the way that blight went through the potatoes in Ireland. So what do you do to try and reduce the chances? You use more pesticides. So instead of using the genetic vigour of the crop itself to protect your food supply, you start using pesticides. So how can we maintain genetic variety? Well, firstly, we do need to accept more variety in the food that we eat. The saddest thing, I think, about the Indian rice in particular is that some of those varieties that are being lost are not just highly nutritious and very locally appropriate, they're also rather beautiful. They're wonderful colours. There's red rice and blue rice and yellow rice. They're wonderful. And on the one hand, you've got Mrs. 4x4 going into Tesco Express in Berkeley Square or somewhere, paying a fortune for black rice, for the sheer novelty value of it, and at the same time, you're losing something just as beautiful and just as interesting in favour of the white basmati rice in India. So if you understand something, just to kind of recap, about where your food comes from and the dependence we have on plants and the choices that are made by the human race about how they choose to grow those crops, then I think you begin to get a handle on some of the things that you need to understand to access some of these more complex arguments in a meaningful way. Genetic modification is another interesting one. I have to confess at this stage, my personal view on genetic modification is slightly different from that of Kew. So from this point onwards, please dissociate what I'm about to say from Kew Gardens, okay? There are those who will say that selective breeding, so if you want to, an interesting point actually. If Walter Raleigh arrived with things that look like this, how did we end up with the crops we've got? Actually, I'm going to borrow back your potato, thank you. Of things that look like this, okay, you know, nice big white potatoes, the kind that we really like. Well, it was through selective breeding. So you took the potatoes that you knew were going to produce these tubers that we like, you grew them up, and you cross-pollinated ones that perhaps produced more potatoes, because traditionally the ones that produce big tubers tend to produce fewer of them. And you take the pollen from one that you like and you put it on the flowers of another that you quite like, and then you take the seeds and you grow them up and you see whether or not they've got the traits that you like. It's quite a fun process if you're not in a hurry. But if you're in a hurry, it's very slow. You have to wait for your generations to go through. One of the things that genetic engineering allows you to do is speed up that process. Because if you can identify the gene that's responsible for the bigness, and you can put it into a plant that's already got the lotsness gene, you can deliberately produce a potato that will produce big tubers and lots of them. And you can do it in a single generation. So that's one kind of genetic modification. And people will say, well, it's not really any different from selective breeding, it's just quicker. Okay. And that's all absolutely fine. And that's very much the official kind of Kew position on genetic modification. For me personally, as a biologist, I'm okay with that, as long as you stay within a species. I have questions, though, when you start taking genes from something that could never have mated with a potato and putting them into the potato. And that's simply because we don't quite know what else comes with it. And that partly comes back to the point about the banana. The fact that we have such a high level of DNA in common with something as different as a banana, and we don't know why, typifies for me the fact that there is still an awful lot that we don't know about how DNA works. And I just personally think we should be cautious in messing under the hood of something rather wonderful and complex that we don't yet fully understand. But I think there are some interesting questions coming out of this. My first question for you is, of some of these fundamental ideas about the links between what we eat and what we grow, what do you really think it's important for the average 14-year-old to understand? And the second one, then, is who should be making decisions about how much we interfere with the genetic diversity of what we eat? So 2 questions. What should 14-year-olds know? And how much should we interfere with the genetic diversity of what we eat? And now I'm going to come